Okay, so today's revision session is going to be a recap on what you've done on graphs and transformations. So we're going to start by looking at translations. So if we've got a function and we're going to add a to that function, then this is a translation of the graph y equals fx by the vector 0a. So that means that we're either translating the graph up by a or down by a. If this a is positive, the graph moves up. If it's negative, the graph translates downwards. We've also going to look at the transformation of y of f of x plus a, where the plus a is inside the bracket of the function. Now this is a translation of the graph y equals f of x by the vector minus a 0. So if we've got, for example, plus 2 here, then our graph would move 2 to the left. If we've got minus 2 here, we'd move 2 to the right. So we're taking the opposite direction to the number given inside the bracket. So the first examples we're going to look at are going to be about the graph of f of x equals x squared. So you've seen this graph throughout GCSE. It shouldn't be new to you. You definitely know the intersection point of y equals x squared is the origin. That's where it intersects with the axes. So if we're looking at the graph f of x minus 2, we're going to translate f of x by the vector. Here we've got a negative 2 inside the bracket, so we're translating it by the vector positive 2, 0. So everything's going to move 2 spaces to the right. So that key point there is going to move over here. And it's going to look something like that. For the next example, we're going to look at sketching the graph f of x and then adding 2 to that function. So we've got y equals x squared. So f of x plus 2, we're going to translate f of x by the vector 0, 2. So everything is going to move 2 in that upward direction. So that intersection point with the y-axis here at the origin is now going to be at 2, and everything is just going to move 2 spaces up. And that is the graph of y equals fx, and then add 2. The next type of transformation we're going to look at is stretching. So if we've got y equals a f of x, so we're multiplying our function by a constant a, this is a stretch of the graph y equals f of x by a scale factor of a in the vertical direction. So if, for example, we had y equals 2 f of x, everything would increase by 2 in that vertical direction. It would stretch by a scale factor of 2 in the vertical direction. Similarly, if we had y equals a half f of x, everything would be halved in that vertical direction. The next one for y equals f of ax, often a lot of people have misconceptions about this. A lot of people think that it's a stretch by a scale factor of a in the horizontal direction, but actually it is a stretch of the graph y equals f of x by a scale factor of 1 over a, so the reciprocal of a in the horizontal direction. So for example, if we had y equals f of 2x, then everything would halve in that horizontal direction. if it was y equals f of a half x, everything would double in that horizontal direction, so it would get bigger in the horizontal direction. So we're going to look at the two examples now. The first example, we've got f of x is equal to 9 subtract x squared. I've done a very dodgy drawing of that graph. So we've got a 9 minus x squared here. We've got the roots of 3 and minus 3. And we're going to be translating that by multiplying the x values by 2. So this is going to be a stretch by a scale factor of, this time the 2 is inside the bracket, so we're going to use the reciprocal of that scale factor, so of 1 over 2, and it's going to be in the horizontal direction. So on this graph I can see we've got 3 key points. We've got the roots and the y-intercept. Now the y-intercept isn't going to change at all when we translate this graph, because the x-coordinate at the y-intercept is 0. If we were to half that x-coordinate, we'd still get 0. However, the roots here, they are going to change. We're going to half them. So the graph is going to look something like that. And our roots are now minus 3 over 2, or minus 1.5, and 3 over 2, or 1.5. Now the second example, we've now got the 2 outside of the function. So y equals 2 of f of x, we're going to do a stretch by a scale factor of 2 in the vertical direction. So that means all of our y coordinates are going to be multiplied by 2. Again, if I look at my key points, my y coordinates for the roots, they are 0, so these are not going to change. The x coordinates stay the same if it's a stretch in the vertical direction. The only key point that's going to change is this one here. So that's going to double. Let's say 18 is up there, and we're going to have, it's going to look something like that. The last two transformations we're going to look at are y equals minus f of x and y equals f of minus x. Now these are both reflections. The first one, when the negative symbol is outside of the function, this is a reflection of the graph y equals f of x in the x-axis. And then when the negative symbol is inside the function, this is a reflection of y equals f of x in the y-axis. Now if I'm honest, I always have to remind myself of the difference between these two, so this is something we all definitely need to memorise for our exam and for starting year 13. So, looking at the two examples here, we've got f of x is equal to x multiplied by x plus 2, so I've got a root of 0 and negative 2, and we've got our x squared form here, our quadratic graph. We're going to draw the graph of f of minus x, so this is going to be a reflection in the y-axis. So it's as if we've got a mirror lined up on that y-axis, and we're going to flip everything, we're going to reflect everything through that mirror line. So the root that is at minus 2 is now going to be at positive 2, and this root here, that's going to stay at the origin. So we end up with something like that. Second example, we've got the graph of y equals minus f of x. So this is a reflection in the x-axis So it's as if we've got a mirror line on the x-axis here, and we're going to reflect everything through that mirror line. Our key points are going to stay the same, and it's just going to look like that.